omega is the angular frequency. Kx minus omega t represent the pace. Therefore, for displacement y as a function of distance x and time t, we got the equation here as I showed earlier. 3 equation and simplify, then we got this equation. This is general equation as a function of x and t. And as you can see, there are positive, negative here. Positive, negative represent wave traveling to the left for positive, and negative represent wave traveling to the right for negative. Wave number is a k equal to 2 pi divided by lambda. The unit is radian per meter. Angular frequency omega, unit is radian per second. Omega equal to 2 pi f. Okay, the period t is in second, 2 pi divided by omega, or equal to t1 over f. Pace is a kx plus minus omega t. Unit for pace is radian. Pace is the angle. Pace speed, v. There are 4 equations of pace. It depends on the information given from the question given. First one is distance traveled divided by the time, or you can use a lambda divided by period, f lambda, or omega divided by k. K is a constant. What if the displacement is not 0 at t equal to 0? Then we generally express the wave in the form y x t in the function of x and t equal to a sine kx minus omega t plus psi. So the difference is here we just add plus psi. Okay, because of at t equal to 0, the displacement is not 0. That's why plus psi here. Pace psi is a pace constant. From the graph here, as you can see, the psi is traveling to the right. So then, that is why we put a plus here. Don't confuse with this sign. This sign is represent negative, represent wave traveling to the right. Psi and positive sign and negative sign here is different. This one for psi. This is summary of the wave equation. There are 2 summary. Okay, the first one, at t equal to 0 second, x equal to 0 meter, the equation is y xt a equal to a sine kx plus minus omega t plus minus psi. Remember, plus minus represent the wave travel to the right or to the left. If let's say the question asks for the velocity, we just integrate from the equation of displacement here, so we can find the v. You have already learned how to get this equation in part 1, if I'm not mistaken. So then we integrate, we got the a omega, then sine change to cos, kx plus minus omega t plus minus psi. Psi, if there are psi, if x is not at 0. But we need to put the psi here because this is general equation. Alright, so then if let's say the question asks for the acceleration, so we just integrate the v here. So we got the equation. Cos integrate, we will get negative sign. So that's why there are negative here. Negative a omega squared sine kx plus minus omega t plus minus psi. So this graph represents the sine graph because the displacement is start from sine. So as you can see, it start at t equal to 0, x also equal to 0. Then the second graph represent the cosine, the cos graph, because of at t equal to 0, x is at a meter, which is at the maximum height and amplitude. So we use the equation vxt a cos. Cos at t equal to 0, but the x is not at 0, x already at a meter, maximum height. So plus cos kx plus minus omega t plus minus psi. Same goes here. If let's say the question asks for the velocity, then we just integrate from the equation of displacement. So we got the velocity equal to negative. Why negative? When we integrate the sine, the cos, so we get the negative sine. Then negative a omega sine kx plus minus omega t plus minus psi. And acceleration, integrate again from the velocities, we get negative sine change to cos a omega squared cos kx plus minus omega t plus minus psi. Then let's proceed with example. A sinusoidal wave traveling in the positive x direction. Highlight the information given. Positive x direction has an amplitude of 15 centimeter. Okay, wavelength 40 centimeter, and frequency 8 Hz. The vertical displacement y of the medium at t equal to 0, x equal to 0 is also 15 centimeter. In A, you need to find the angular wave number, k, period t, angular frequency, omega, and speed of the wave. The second one, first one is k, which is a wave number equal to 2 pi divided by lambda. 2 pi is a constant. Lambda already given in the question. So then just substitute 40 centimeter here. So we got the radian in 0.175 radian per centimeter. Centimeter here because the lambda is centimeter. Omega 2 pi f. F already given. So 8 per second. So substitute we got the 50.3 radian per second. For period equal to 1 over f or to omega t equal to 1 over f. So just substitute the f here. So we got the value of period. V equal to f lambda. F is from here given already 8 per second time with lambda 40 centimeter. So you got the velocity 320 centimeter per second because lambda is given in centimeter. Then we need to find the pace constant and wave function. So because of A is given 50 centimeter and Y is given 15 centimeter also at L equal to 0, T equal to 0. So refer to the function equation, which is Y equal to A sine kx minus omega t plus psi. The question asks for the psi, so we need to put the psi equation in here, even though the x equal to 0, t equal to 0. So then, here, Y, we substitute the value of Y, 15, and A, 15. K we found in part A, but K here is supposed to be 0.157. There are typo error here, so just substitute again. You try to calculate by your own. Time with 0, so we get 0. 50.3 time with 0, we got 0 plus with psi. So then shift sin 1, so we got a psi equal to 90 degree, which is equal to pi over 2. Pi over 2 is 90 degree. So then we can find the wave function. Substitute all the information we have. 15 amplitudes A sine kx minus omega t plus with psi. So this is the equation. Right? Let's try another example. This one you need to solve by your own. I just give you the hint how to solve the equation.